Yes, my first ever live stream. Gonna try to keep it short to around 30 minutes. We're gonna be talking about Webrtc, PeerJS, Orthoverse, and Pong, of course. And we're actually gonna start with Pong. And what we're gonna do is we're gonna start here. This is the landing page of this application that is basically a DApp. It's got kind of some Web3 technologies built in. It connects to your wallet, and it verifies whether or not you own land in the Orthoverse. So the Orthoverse is Orthoverse.io is care from a big project where it's basically a metaverse, and it's very similar to Roblox. You can build on your own land. You have to, I guess, pay the gas to kind of um, find display your land, but it is somewhere on the map, and then you can build on your land, and you can basically go in, and there's a little bit of a chat in there as well. But the idea came up when I was talking to John Rigler that if you're a fan of a community, you kind of can extend on to a community by building some applications, kind of side applications that interact with, let's say, the smart contract, or in different ways. So that's basically what I'm doing. So Orthoverse is Kira's project, and what I have here is the beginning of kind of a side project that just has a little bit of integration into the Orthoverse, and this is what you're going to see. Now, if I scroll down on the Orthoverse page, you're going to see that I own some land, and this is basically what my land looks like, and it's got a name, which I'm going to try to pronounce here. Orthoverse. Okay, well, I tried my best. But this is what my land, or at least the land token, looks like, and everyone would have kind of their own unique land token. So I've got the land name, the picture of the land, and if I want, I can enter into the Orthoverse metaverse, so to speak, and I would be able to find my land on the map and go there and build something. So in what I've done here is I've created a separate application that is just going to verify that whoever's connecting to it actually does have some land in the Orthoverse. So what I'm going to do is I'm going to open up MetaMask, because there's a few steps actually. I'm already kind of connected. Okay, got it. I'm going to first, just for fun, I'm going to switch to Polygon, and I'm going to disconnect from this site. Okay, that didn't quite work. Okay. So there was a little bit of dynamic refresh here under the covers with the application, but it didn't quite work. I'm going to refresh the whole page and see. Okay, perfect. So this is what you would normally see when you first come to the landing page. You have not connected your wallet to this website. So this is the first step. We're going to connect the wallet. Okay. And it actually tells you explicitly kind of what you're allowing the site to do. So it might be a little bit small, but what's saying is that it can see your address, it can see your account balance, activity, and suggest transactions to approve, but obviously it can't just approve transactions without you approving them. So it's basically read only unless it asks you to do something, and then right. So I'm going to connect. Okay. Now, what's next is that because Orthoverse is on the mainnet, on the Ethereum mainnet, we inside the JavaScript, we're actually tracking things, and we're finding out that even though the wallet is connected, it's currently pointing to a different chain. So we want to switch to the Ethereum chain, and that's something that you can do under the covers. You can get prompt the wallet to switch chains. So now that I press the button, it's going to ask me allow the site to switch the network from Polygon to Ethereum. There is a caution here: switching networks will cancel all pending confirmations. Well, I don't have anything going on right now, so I'm going to switch the network. Okay, so now we've connected our wallet. We are now on the correct chain, and now we can actually just double check that you actually have Orthoverse token. Now, if you don't have your token, then you can go to orthoverse.io, which is where we were before, and there would be a button here saying reveal your land. And I think, if I'm not mistaken, you just have to pay for the gas, which, obviously it varies depending on the time of day and network congestion, but, might only be a couple bucks. But, I always have to keep an eye on the rates. So I already have my token in this wallet. So I'm going to say log in using my Orthoverse token. Now, really what it's doing is just making a query to the Orthoverse smart contract and just verifying that my wallet address is actually a landowner. And here we go. So you can see that, nice little greeting here. And it's got a picture of your land. And it's prompting you, do you want to play Pong for the Orthoverse? Now, down here it says challenge another Orthoverse player to an epic game of Pong. So the idea here is that you can actually play another player a game of Pong, and this is kind of where the WebRTC PeerJS technologies come into, which I'll talk a little bit about later. Now, if you don't have another player to play with, you can actually play with yourself with two browsers open at the same time. I'm going to click on play, and it's going to take me to this second page. So right now, my application only has two pages. It's got the landing page, and it's got this Pong page. I am going to duplicate this into a different tab. Okay, and now I'm going to kind of break it up, split it up, and do side by side here. Okay. Alrighty. So in here, and this is using WebRTC and PeerJS technologies, and we can talk a little bit more about it. If we don't have much time, we'll probably just do it in a different session. So the idea is someone comes in here, the first player comes in and wants to challenge another player. So what they do is they set up the game by choosing what scene they want, what the difficulty level is, and this code is really the key in terms of the WebRTC and PeerJS communication. This is the code that the other player has to put in, and I'm just simply going to copy it over here. Now you have to kind of talk with the other person through some other means, maybe, through chat on, instant messaging on LinkedIn or Twitter or whatever is the case. You have to communicate with them and give them the invite code so that they can enter it and then you can start. But what's happening when you start to choose? You're actually setting up the game details here. These are all free images, and I provided the credit below. They come from pexels.com, and you can see the credits below. So you can choose an interesting picture, which will become basically your battle scene, your background image. And this image is actually going to be shared over the wire to the other player. So the other player who is joining your game will actually see the image um, on their side, as well as the difficulty level. So right now there's 3 difficulty levels, and they go into kind of the speed of the Pong ball, and also you have a paddle, and if it's easier, then your paddle is larger. So maybe we're just going to do the easy mode for now. I don't, I won't maybe want to do the more interesting, maybe a brighter image. Okay, it's okay. Not bad. Okay, I think I already copied this. In fact, yeah, I copied it over here. So when I'm ready, because I'm playing myself, the other player presses join, and there we go. Depending on if you're full screen, you're not full screen, the board's going to be much different size. You play two until one side gets 5 points. I'm going to take a break here and talk about what's on the screen. So um, you can see these roles are kind of reversed. So the person who created the game is on the left-hand side, and they're seeing their land or your land on the left, and the enemy land, the person who you asked to join you to play, is on the right side. Now, they're exactly the same image because I'm playing myself, but normally you would see 2 different lands here. And these are both lands that are in the Orthoverse. Now you can see that I'm not playing very well, so this game's going to end pretty soon. The other player, the player joining, is kind of seeing themselves on the right-hand side, and it's going to say your land, but you would recognize hopefully your land. Every land looks a little different, and the left-hand side for them would be the enemy. These colors, probably going to tweak them. They don't look that great, but the game is over. So the person joining won the game 5-4. Okay. So what we can do is talk about some of the technologies behind. So we did mention already about the landing page, how it has Web3 code to basically query. We're not using or I'm not using Webrtc. If I take a look at some of the files here, and scroll down the code, you're going to see some examples. There's a lot of comments in here. So here's an example where we're actually interacting with the Orthoverse smart contract. We're sending it a specific hash for function, um, and we're passing it, the address of the wallet. And depending what the function is, the function I think is like at castle level or something. So that is going to return the castle level, and we're using a very low level um, JavaScript API. We're using the Ethereum object directly in the browser. We're not really using any kind of helper library like, you know, Ether.js, for example. So these are how we kind of hand coded uh, some of the requests on that first page. Now, in terms of WebRTC and PeerJS, I'm going to come back over here and briefly talk about, um, well, let's leave that to a different stream. What we're going to do instead is we're going to go to the open source Pong game that I integrated into this project. So this open source Pong game uses the lower level WebRTC, which enables the peer-to-peer communication. And this page, that's mipexela.com, that talks about the WebRTC Pong project and how it uses WebRTC technology, like, for example, stun server, turn server, um, the NAT issue, for example, with real-time communications, and talks about the actual game mechanics. Because the way when you play a game with someone else, you want what they see on their screen to basically be the same thing you're seeing on your screen, even though there's an inherent latency between the two sides. So this article actually talks about this, how information sent from one side only reaches the other side at a certain point. Information sent from your side only reaches the other player at a certain point, and then there has to be some very interesting technology in the JavaScript to try to get both sides to experience basically the same UI at the same time, and dealing with some latencies, right? So a lot of interesting technical reading here, but that's for um, another day. The other thing about WebRTC, and I'll just talk about it very high level, is that it requires a signaling server. You need, and this mipexela.com has some PHP and a SQL backend, but we did not want to have an actual backend. And the reason is that we actually just want static code. We want static HTML files, static JavaScript. We can put it anywhere. We could, maybe even put our application on, the blockchain or Filecoin, or, it's just flat files that you can access. We don't really want server-side code. So even though we have this web server, ortho1.vercel.app, we're not actually, where it's basically just serving flat files. And in fact, when I test this on my computer, I use a npm package that's called http-server, which basically you just run it in a folder and will just serve files from that folder. When you make a request, it'll start up a mini web server on port 8080, and you start requesting files. So I think this is an interesting project because it does not require that server-side code. Everything is really client-side, and all you need is the static files. So how did this happen? Because WebRTC needed a signaling server, and even this Pong project here, you can play the game, and it has a similar interface, but obviously without the Orthoverse additions um, and the difficulty. But they use PHP and SQL backend, but we didn't want to do it. So how did we do that? So this is where PeerJS came in. So if I go to PeerJS, PeerJS is, whereas WebRTC is built into the browser, um, but requires that PeerJS is like a JavaScript library. You put a script tag in, and then you call these functions, and it has PeerJS has its own stun and turn servers that will basically take care of the rest. So you don't have to worry about having this signaling server, which is really kind of the key point. You don't have to run your own custom server code to enable it. PeerJS is really what's going on. So what we did was take the WebRTC um, repo, and then we migrated it to use PeerJS so that we can do everything with just static code without a backend. And then we enhanced the game so that you could see you can pass additional things along. Let me go back here. You can push additional parameters along, for example, such as, this being number, which is just a number, and the difficulty level, and changing different things in the game. And um, there was an issue also with sometimes when you hit the ball off the paddle, it would go off on a very vertical angle. It would take a while for it to get to the other side. So some of the enhancements of the Pong game was to make sure it's within a certain angle of kind of the horizontal line, so that you're not going to take forever waiting for the ball to reach to the other side. Anyway, I think I've done going over this stuff at a high level. I'll do my next stream in um, probably a week from now and figure out what the topic is for that. But I appreciate everyone uh, joining, maybe commenting and watching, and I'll talk to you guys later.